Okay, so this week we keep going with our probability and stuff. So this topic is called counting principle. So this is a lot of words you have to read, but it's very simple work. So you can use the counting principle to find the total number of outcomes. So if one activity can occur in n times, so whatever number of times, and another activity can occur is in m ways, then both activities can occur in n times m ways. So you combine the activities. You just combine the the number of outcomes to get the number of outcomes. So examples. I'm gonna do a couple of examples. You guys do the ones that are required that I post on your assignment. So to leave her office, Karen can choose between 3 sets of stairs and 7 doors. How many ways can she leave her office? Very simple. 3 ways, 3 sets of stairs times 7 doors. The answer is 3 times 7, 21. Super, super easy, right? Okay. All right, so I'm going to do number 3 then. There's a few examples that change a little bit, depending how many situations you have. So you got to really read what you have. All right, it says a class has 11 boys and 16 girls. How many ways can the teacher choose one boy and one girl? Super simple. Again, we multiply 11 times 16 girls. That is 176. That's called the counting principle. You have 11 ways that can happen times 16 ways that can happen, then you multiply them both. And that's the total ways that the teacher can choose one boy and one girl. All right, let's see. Number 4, I'm gonna do number 4. So it says a dinner menu consists of 5 appetizers, 12 entries, and 3 desserts. How many ways can someone order one appetizer, one entree, and one dessert? All right, so you multiply the 3 numbers. So that's 5 appetizers times 12 entrees times 3 desserts. And you get 180 ways. So 180 is how many ways can someone order one appetizer, one entree, and one dessert? That's the answer. That's it, guys. Let's see. Let's see another example, like a different type of example. So in this case, I think this one is pretty popular because when you think about it, like when you're trying to come up with a number or like a code or something like that, you think about this. So it says, how many ways can someone randomly dial a 7-digit phone number? So if you choose numbers from 0 to 9, if you count how many numbers counting 0 and counting 9, you really have 10 possibilities, right? So so that means that 10 possibilities. And with a 7-digit phone number, then you have 10 possibilities to the power of 7, which is the 7-digit number. If it's 8-digit numbers, then that would change to 8, right? But since phone numbers are 7 digits, then you have how many numbers? So from 0 to 9, there are 10 numbers. So 10 to the 7th power, which is 10 million. 1, 2, 3. 1, 2, 3. All right, so that's how many ways. That's how many ways someone can randomly dial a 7-digit number and will get different numbers, different combinations. All right. Okay, so number 9, I'll do this one too. This one has to do also with exponents. So a quiz contains 5 multiple choice questions. So 5 multiple choice. Each question has 4 answer choices. So that means that you have 4 answer choices and you have 4 answer choices, but then you have 5 multiple choice questions. So this is like the 7 here. So it's going to be 4 to the 5th power. And then your answer is 1024. It says, so this is the ways that questions can be answered. 1000 was 24. So think about when you're doing your test. That's crazy, right? All right. So let's move to the second page over here. These two questions I'm gonna skip, and it's because there is some algebra involved in this, and I'm not really. I kind of want you to understand the concept of counting principle and not, getting to like more, you know, trying to figure out some other concepts and all that. So let's skip to the probability examples. All right. So I'm gonna do number 13 and 14. All right. Okay. So in this one, we're gonna involve something called the tree. Something called, I'll tell you the name right now. It's called the tree diagram. So what that means is that not really we're gonna kind of draw a tree, but you don't need to. You just have to understand the concept, what we're combining here. So a coin is tossed 3 times. What is the probability of getting heads just once? So first you have to count your possible outcomes. So your possible outcomes are, well, if you toss the coin 3 times and you have each outcome, you have either heads or tails, so that's 2. That would be 2 times 2 times 2, which is 8, right? Now, what's your favorable outcomes? So you have 3 ways that could happen, right? You have one way, it would be heads, heads, tail, right? The other combination, because there are 3, right? There's 3 times that you're tossing the coin. So the first combination would be if you get you get heads and tails. Then you have another combination which is heads, tails, and heads. And then you have a final combination which is tails, tails, and heads. Now, notice that in each of the situations they're different, right? But these are the possible combinations that you can get. All right, so now they want us to answer what is the probability of getting heads on just once. So just once. So then, all right, then you say, okay, so there's 3 combinations here, so there's 3 times that you can throw it and get that, and then 3/8 total possible outcomes. And that is your answer. Now you can write this as a percentage, which is you divide 3 divided by 8 times 100. Times 100 is 37.5%. Okay, so then the next one. It says a month is chosen at random. So think about how many months there are in the calendar. So there are 12. So then a standard die. So a die, you roll the die and the numbers are 1 through 6. So a standard die is rolled. So at the same time that you're choosing a month randomly. What is the probability of getting February, then a number less than 5? So we need to think about how many numbers are there in a die that are less than 5. So we think about the possible outcomes. So possible outcomes are, how many months are there? 12. And then how many numbers are there in a die? 6, 1 through 6, right? So that would be 12 times 6, that's 72. And then favorable outcomes. That's like this possibilities here. So the favorable outcomes would be having the number. So numbers 1, so the numbers that are less than 5 in a die would be 1 through 4, right? And what are the possibilities to get the month of February and a number less than 4? Then it would be, so how many? So favorable outcomes You get February, and then you get a 1. Then you get February, then you get a 2. Then you get February, you get a 3. You get February, and you get a 4. And that's it, because 5 is not included, because it has to be less than 5. So then now we have 4. We have 4 favorable outcomes over the ones that the total possible ones. So that would be 4 over 72. You can turn that into a percentage. 4 divided by 72, which is 0.05 times 100. That would be 5.6. 5.6%. And that is the combination when you combine the counting principle with probability examples. And these examples that we did before are the examples of actually the fundamental examples, like the actual concept of counting principles. All right. Okay. So I hope this helps. Please join my classes. Your classes are Tuesdays at 11 a.m. Thank you very much. See you later.